All right. Hello, everyone. I've got us at the top of the hour here, so we're going to go ahead and kick off our webinar. I want to welcome you to the NCAT um, Research to Implementation webinar series. This month, we've got an exciting topic. We're going to be talking about environmental product declarations and where these things have been going the last several months. There's so much uncertainty in what's going on there. There was a tremendous amount of funding around this last year, and things have certainly gone a little different. So, as always, we're joined today by Nathan Moore. He's the Assistant Director for the Test Track Research here at the National Center for Asphalt Technology. He's responsible for overseeing the programs at the Test Track Research. Prior to that role, Nathan served as a lab engineer for 8 years at NCAT, and he specialized in balanced mix design and pavement friction. He's got his bachelor's degree and his master's degree from Auburn University in civil engineering. He's licensed professional engineer here in Alabama. And interestingly enough, he had 3 of the 4 teams for the Final Four pick, but we didn't get the one we wanted to win. I wanted to win. Right. So there's plenty of folks in Florida that got their team to win. We also have with us today Tom Harmon. So Tom joined the NCAT family about a little over a year ago, after 33 years with the Federal Highway Administration, and he serves in a variety of roles there with the feds. Tom's journey with the Federal Highway Administration started in 1990s with the development of SuperPave while running the mobile asphalt labs. He's also led FHWA's pavement research team at Turner Fairbanks, the training and technical support at the Resource Center. He led the Everyday Counts program, and he finished up his career running the NHI, sort of the National Highway Institute there. So I'm glad to have Tom. And our guest today, we have Dean Schmidt. He has 18 years of experience with PennDOT, including 12 years specializing in maintenance operations. Dean serves as the regional maintenance advisor, and he's on several different committees where he focuses on environmental product declarations, or EPDs, for sustainable project delivery and furthering PennDOT's commitment to advancing innovation and sustainable practices. Dean graduated from Point Park University with a bachelor's degree in science of civil engineering, and he is a registered professional engineer. So that's our lineup for today. I want to remind you, please keep yourself muted. Type any questions you have into our chat box so that we can ask our questions in there, and we'll get to those at the end. Given that, I'm going to turn time over to Nathan.
So many of you guys know the drill, those of you who have been in these before, but the flow of this webinar is going to be, I'm going to just very briefly introduce this topic and briefly discuss kind of what it is and NCAT's history related to, and we talked about EPDs, but we're also talking about LCA and LCCA as well. And then I'm going to hand it over to Tom, and Tom will go in much more detail. I don't like stealing our NCAT PI's thunder, so he'll go in significantly more detail than I will. And then we'll kind of hear from folks outside of NCAT. In this case, it's Dean, and then we'll we'll have a closeout and do Q&A. One thing I do want to make sure is we have a chat. Please do not wait. Don't feel like you have to wait till the end to input your questions. Go ahead and get them in the chat. Some of them may be simple enough that we can respond via text. Others, they may be really good questions, and it's probably best to have discussion at the end. So please, 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 if you have questions, put them in the chat whenever you think of them. So we're going to start off with LCCA and LCA history at NCAT. So when you think about LCCA, that specifically is life cycle cost analysis, and we've done numerous studies looking at LCCA. And really what this is it's just financial accounting of payments. How much does it cost? How long does it last? Things that last longer, you're saving more money, and how do you kind of get credit for longer lasting pavement? And so we've done this work over a decade now, and one of the first published reports that we wrote was written by Randy West for ALDOT, where we just kind of helped ALDOT review their LCCA policies and procedures and made quite a few recommendations. You can really get in the weeds when it comes to how to do financial accounting for pavements. I mean, things like material. How do you deal with inflation? How do you deal with variable material costs? How do you deal with the price of oil? How do you deal with user costs? Lots of questions like that. And so, in order to do it right and standardize it, there's quite a bit of research that needs to be done. We also did quite a bit of work between about 2018 or 20, maybe 2017 and 2020, and there's a handful of reports written on our NCAT website for some LCCA work sponsored by NAPA. And that was really more specifically solving some specific problems and answering some specific questions related to LCCA. So it's like specifically like how do you use how does ride quality, how should that go in and affect user costs, which would ultimately end up being part of the financial accounting in the use phase of asphalt pavements. Jim Musselman and Randy West did some work on how do you deal with end of life considerations. So when an asphalt pavement is done, it has value as recycled material. So how do you account for that? So there's been quite a work done on LCCA. As you move to LCA, which is life cycle assessment, this is more of eco accounting. So if you've got financial accounting on the LCCA side, LCA is more of an environmental accounting. Kind of how much energy was used, how much carbon was used, how much, those kinds of questions. And we haven't done as much work, although anytime you talk about sustainability, you see what the triple bottom line, which I'm showing you here, which you're trying to make sure that you're meeting the criteria to serve the people, profit, and planet. So LCA is kind of more on that planet side. And we did a big study. Richard Willis actually did a big study looking at the 2012 Green Group. That was a group of test track sections on the NCAT test track with high recycled contents or various innovative recycling techniques. So there was some work that came out of that. But more recently, we have heard about EPDs, and EPDs are environmental product declarations. And I'm not going to steal any of Dean or Tom's thunder, so I'll just kind of be really brief here. But essentially, this is how do you turn an asphalt mix, a ton of asphalt mix, into a standardized and push it through a standardized process so that you can evaluate environmental impacts. The best way that I heard this explained whenever I was learning it, and kind of what has stuck with me is like a nutrition label, where you can look at this nutrition label that I'm putting on the screen, and if you have some intuition, you could probably figure out, what it is, kind of, but you can't get any brand information. There's no secret sauces that you can gather from reading a nutrition label. It's just kind of the basics, and it's a standard process. And that is kind of that's the idea behind EPDs for asphalt mixtures, is a standardized process so that you can take into account transport and materials and energy at the plant, those kinds of things. And then hopefully even moving forward into the future, you can take into account construction costs and haul distances and end of life considerations as well. So our body of work around EPDs is significantly smaller than around LCCA and even LCA, but primarily just because it's a newer concept. And Tom's going to talk a lot about this. We've done some case studies using current mixes and previous mixes from the NCAT test track, and an ongoing project that we're working on. Dr. Suri Gadaganti is working on this, helping state of North Dakota collect plant data and looking at state-approved job mix formulas to help develop EPD benchmarks. And it's kind of a question of where does it go from there, given the kind of the current state. But that's really kind of a brief summary of the work that we have done and kind of are doing. Honestly, at this point, I will turn it over to Tom, and he can give you a lot more information on this. So, Tom, I'm going to stop sharing and turn it over to you.
Fantastic. And that was a great introduction to the topic. I am going to do a deep dive on at least one study from the test track, as we always do, and have a little fun here as we go. So my session's entitled the 3 E's, which is another way to look at it. Engineering, that's where we're going to get into things like pavement design, balanced mix design, getting the right mix. The economics, which is the life cycle cost analysis, and then how we quantify the environment. When I went through my engineering classes and we talked about the threes, a friend of mine coined it as it's intertwined. So there's an intertwinedness to these three things. You can use that word if you want. If not, you can just let it slide. But you can't have one without the other. If you don't have good engineering, even if you have the lightest environmental footprint, it's not going to last long. You're going to have to replace it. And they interplay with one another. So to show in a more graphic fashion, LCA. So for life cycle assessment, it's a systematic analysis of the potential environmental impacts. So we start in the upper right with how we got our materials from the refinement to the aggregate sourcing at the quarry or the pit. Then those are hauled to the production facility, and then they're produced. You'll notice there's a little bit of battleship going on here. There's a standard process under ISO where when we get our materials, we call that A1. When we do our transport, we call that A2. When we get out to production, that's A3. And we're going to talk a lot about that because that's going to frame out what our EPD is. During the construction side, there are two elements of battleship there, A4 and A5. The use phase is looking at emissions coming off the vehicle traffic and mix. Typically, when we're dealing with pavements, we exclude the use phase because that's outside of our industry. The only place where we might have slight impact is on the ride quality. And then we get into maintenance strategies. And then when we recycle it or end of life, that gives us our full life cycle assessment, cradle to grave. And as Nathan just said, when we talk about LCCA, that is our financial accounting, and LCA is our eco accounting. Now in this, there's some rules that come out. We start out with product category rules, and those have been developed and are published. If you go out to the National Asphalt Pavement Association, there's a wonderful website that'll walk you through all of this. And that's the rules of how you're going to capture, measure, store, and report information that leads into these other things like EPDs and LCA. So the foundation of this is, well, how do we collect the data and in what things? So the next building block is this EPD, which is going to tell us just how many calories are on the side of our breakfast cereal. And that provides us product information from that quarry refinement all to the project site and placement. And then lastly, if we have the data of life and what we're going to do for our maintenance strategies, we can come up with an estimation of the environmental footprint across the life. There's some great guidance on that, both on the NAPA website and my former colleagues with the Federal Highway Administration. So let's start out with asphalt mixture EPDs. So this is that circle we had just at the beginning for the pavement life cycle. And you notice I just have A1, A2, and A3 highlighted. If you go to NAPA, the current eco-label program, I have some statistics. Dean has newer statistics, which is going to be exciting to see. This is often referred to as just cradle to gate, and think of that gate as the gate of the asphalt production facilities. When you go out to the plant, that's where we stop counting when we talk about an EPD. So the first question, if I have two mixes with two different EPDs, is it fair to compare environmental impacts just on cradle to gate? Well, the only way that would be appropriate if I knew that they had the same application and the same life, and we're going to have all the everything else the same. But as we know from one mix to the other, it would be inappropriate to take an SMA and compare it to a base mix. They have very different EPDs. We want to have things that are similar, and that's where that full LCA comes in. So we want to make the considerations throughout the entire life. So in a second, I'm going to show you a screenshot from the NAPA website, and I was going to update it today, but it changes every day. So the Emerald Eco Label Program, as of the beginning of February, there were 161 organizations, so asphalt contractors, that had put data in for over 500 asphalt plants and over 4,000 individual mixes we had product declarations on. You can go to this website that's down at the bottom, or you can just simply type Napa Emerald Eco Label and have a chance to go and explore that. I'm going to, in a moment, take an EPD, and it truly was a random EPD. I just grabbed one out to see how these A1, A2, and A3 interplay with one another. And let's show that here. So when you go, there's a PDF document for each mix that you can pull down. It tells you the production facility, who it's for. It'll tell you about the performance grade asphalt, the nominal maximum aggregate size. On the next page, it'll give you very general breakdown of aggregates, and the aggregates will be very generically named. As Nathan said before, we're not giving away any secret sauce on contractors' individual mixes within EPD, but the secret sauce is actually behind the database. So the contractor puts in all the real information, and then when you get the product declaration, that is masked, but the environmental footprint is there. So when we look at A1, A2, and A3, so materials, transport, and production, those are measured in a unit of kilograms of CO2e, either per metric ton, which is common in Europe, but in the US per US ton. So the numbers I'm going to show you, it's a little mixed melody here. We're going to have kilograms per US ton. So for materials, what would that number look like? Remember, this is a random one I pulled up. So for the random one I pulled up, I get a value that's right around 32. It's carried out to 2 decimal places, but it's around 32. Would I expect the transport number to be about the same, significantly higher, or way less? Well, in general, unless you're in a few states like Florida and others that have very long hauls, A2 is very small. It's a small footprint. Think of all the energy you need at a quarry and at a refinery to get those numbers out. Here in this particular one, it's 1/3 of the A1 value. Now, A1 to A3, when we look at those values, this is now heating up the plant, producing and getting the mix up in the silos. That number historically, when I look at them, is very similar to A1. For this random one I grabbed, it's slightly lower. You add them all up, you get 65. So truly a random pull out of the database at Napa, but it gives you a sense of feel for what's going on. So here we have more energy required and associated emissions with the refinement and production of these materials. Transport, I've seen that number below 5, and production usually somewhere in line, A1 and A3. The National Asphalt Pavement Association shows this in a very simplistic form. This is a typical simple mix. And I always remembered when I first started learning about EPDs, you drive 55 a lot of times, typically around 55 kilograms per US ton. Here we have a simple 5% asphalt mix. The transport's 22 miles. And then look, things that are very important for that A3. What type of burner fuel are you using? All the energy sources coming in. So with that, I'm now going to pivot to the test track and show some smiling faces, one of which you've seen. So here we are going to go and show some data from the test track. And I always like this. It's America's Asphalt Pavement Proving Ground. We have a sponsor meeting coming up, and I hope everybody online today has had a chance to go out and walk this. It's just pretty darn amazing. My favorite statistics, 1.7 miles of love that you can drive around. There's one of the trucks going around one of the sections. And as of the last cycle, we broke the 10 million mark with regard to easels applied. And the miles traveled is, it's a 23 round trips to the moon and at least 17 stops at Buc-ee's. I just had a chance to go on a trip with several of my NCAT family. And when we drove past the Buc-ee's down in Texas, for some reason, the rent-a-car had to pull over and stop. So a lot of good stuff happening. We're now trafficking our 9th research cycle. A lot of good things going on there as well. So with regard to the test track, here's a QR code. It's a great place to go out and just scan it. It'll take you to many of those reports that Nathan alluded to at the beginning. Lots of goodies there. Here's our sponsors for the cycle that I'm going to be talking about. And you can see here, this is a potpourri of DOTs, contractors, material suppliers. It really is a proving ground for everybody. So For this study that I'm going to highlight that has both life cycle cost and life cycle assessment, we're going to go to the state of Texas. And my researchers here, we have Randy, our director, as well as research engineer, Fan Yin, Ben Bowers, who is truly with Auburn University, but does a lot of work with NCAT, and Suri Gadagante as well. And he's our guru when it comes to all things LCA. So for the Texas experiment, it started out as a balanced mix design experiment. They wanted to see how their volumetric mix design back in 2018, which is super paved base, would compare to this newfangled balanced mix design. They were placed in next to each other in S11 and X10. It was a classic, we're going to mill down 2.5 inches and we're going to do an inlay of 2.5 inches. When we mill down the 2.5 inches, we had about 10 to 20% cracking area. Very common that agencies don't go down to get all the cracked material up before they place the next section down. So Texas thought this was a very realistic experiment from that standpoint. For the mix designs, the volumetric mix design had a total binder content of 4.7%. 20% of that was wrap binder replacement. When we went through the balanced mix design, looking at rutting and cracking, we got higher asphalt content, 5.5%. And then after this experiment had been trafficked for a cycle, Texas went one step further and put down an additional section that was designed using balanced mix design, and everything else pretty much the same. In this one, we had slightly lower binder replacement, 19 instead of 20, and the optimum asphalt content was 5.3. Other volumetrics are there on the screen. So for Texas's balance, they wanted to assess cracking, because this is a mill and inlay, using the overlay tester. And the parameter that we look at is the progression rate, or beta. Lower values are better. And then comparing that against the Hamburg wheel tracking test, again, lower values are better. So when we look at these mixes, they plot up as such. Superpay volumetric is not in the sweet zone. So immediately you're thinking we might have some cracking occurring in that earlier based on a balanced mix design philosophy. The one in S10 was definitely in the sweet zone. And then N6 was right at the edge, but still fully met what we would consider a balanced mix design. This is a cracking experiment, and you can see here, every cycle we get 10 million easels in. And after the first cycle, the blue line is superpay volumetric. We're at about 10% cracking at the end of that. Just starting to see cracking in the balanced mix design section. And then for the new one that went down in the second cycle, no cracking had shown up after 10 million easels. So Texas elected to load the first two an additional 10 million easels, and we had to discontinue loading at right around 15.5 million. You can see here in this photograph, we're starting to see severe cracking. Our threshold was 20% cracking. And if you compare that to the balanced mix design, very conservatively, we got another 5.5 million easels applied to that section. And at that point, we had just reached 10% cracking level. So for our analysis, we're going to conservatively assume that that mix lasts 1.3 times longer than the superpay volumetric mix. So to do a cost analysis, we need to know how much this stuff costs. Texas uses a 40-year analysis period. Their discount rate, which looks at interest and inflation, is 3.72%. For the 12-year performance period of the volumetric mix, we're going to use that as our benchmark, that we would renew it over that 40-year period. And then we would have that 1.3 multiplier on our first balanced mix. The volumetric mix is around $80 a ton. Based on the cost we had. And because of the additional binder, the BMD mix was slightly higher, around 85. This just shows how we would stage that out for volumetrics. Every 12 years, you would see a mill and fill, slightly longer for the first BMD mix, and even longer for the new BMD mix, which based on laboratory and field observations, we think is going to last 30 million easels before it needs to be renewed. In a traditional low bid environment, the volumetric is 6% lower in cost. So we have a 6% increase for both of those because of the additional binder content. So we're just doing low bid alone. Superpave is going to win on this. When we do a life cycle cost analysis using net present value, we see a significant change. A 17% savings with the balanced mix design in the first cycle, and the new one, because we think it's going to have an even additional life, has 36% savings. Now we want to transition into this LCA. Here's the Federal Highway Resource that's out there, a published report. Again, we are not going to include use phase or emissions coming off for this. And this is a research study that Surrey conducted without third-party validation. If you read through this document, it'll talk about a full LCA actually has additional validation that occurs within it. But let's show what the data includes. First off, there's about a 10-minute drive between the production facility and the placement. And in the LCA, the data that Surrey provided me, we have cradle to construction. All of these mixes were produced at the same plant, same haul distance, and the same laydown equipment. So there's no difference in that. So this differential of 10% you see here is very similar to what we would get if we did an actual EPD on each one of these mixes. So slightly increase, and that is due to the energy associated with the additional binder. When we do the LCA, we see similar to life cycle cost analysis, a 17 and a 45% decrease in emissions generated over a 40-year period of these mixes. So one way to look at this is if I just compare emissions to cost, hands down, the Superpave mix, the blue dot there, has the lowest initial cost and the lowest initial emissions, and both the BMDs have a higher cost and higher emissions. But when you factor that out over the life of the pavement, we see them invert. So we see a significant change in the ranking when you actually factor in the total life of the pavement with regard to that. So our challenge when we look at things like low carbon materials is EPDs do not ensure performance. They definitely provide us energy consumption and emissions associated with the production and manufacture of the product. Traditional asphalt AQCs are primarily focused on quality, not quantity. That's our volumetrics versus our BMD criteria. So the good news is we're in a wonderful position with balanced mix design to give us those essential tools to help us actually balance out the cost and the environmental impact as we build out these mixes. So with that, I am very pleased to finish this.
So today I'm going to briefly go over PennDOT's EPD program and how we've implemented it up until this point. So starting off, just to give everybody a brief, I guess, glimpse of PennDOT by the numbers: 40,000 miles of roadway, 25,400 bridges. We have a lot of infrastructure, and we use a tremendous amount of asphalt annually each year. So, you know, we are definitely in a position to benefit from balanced mix design as well as the data collected by our EPDs. So this slide here, I just wanted to give a brief introduction. So I'll briefly go over our team members, where we started in 2023, our journey through 2024, where the bulk of our work took place, and then where we are right now in 2025. Some items that we believe, you know, are in our future, our look ahead, and then just some slight challenges that we've encountered on this journey. And so at the end of the presentation, we'll open up to any questions that you may have on behalf of PennDOT's journey. So with our team members, so obviously this started with an EDC 7 innovation for EPDs for sustainable project delivery. So FHWA was very much the driving force initially with us and a key player or partner in our journey. We ultimately ended up bringing a consultant on board to assist us with some administrative functions. Initially, EPDs were brand new to PennDOT, and so as such, there was a great deal of literature that we had to sort through and just wrap our heads around what EPDs were and how they were going to be beneficial to us. So industry stakeholders, we were very fortunate that we had some contractors across the Commonwealth that were very much ahead of us in championing EPDs, and they were already working close with the Pennsylvania Asphalt Pavement Association and the National Asphalt Pavement Association. So we were able to lean on our industry initially and learn from what they had already began to look at. And a big part of industry's desire was some of the I'll say the commercial projects that they were getting involved with, Amazon, Walmart's, and so on, wanting to know what that global footprint or global warming potential was of their mixtures. So we all were kind of going on this journey with similar goals in mind. So in 2023, or where we started, in December of 23, PennDOT had conveyed the department's commitment to EDC 7's initiative for EPDs for sustainable project delivery. So the communication included a summary of what the EPDs were, and we provided this information to our business partners, both internal and external. We wanted our stakeholders externally to see what our draft implementation plan was and what our goals were and how we were going to roll this out. So that whole process was developed with FHWA's influence and guidance. And we originally were planning to take the approach of, I'll say, approaching all materials with similar, I guess, at a similar pace. And so we'll get into that in a couple slides. So beginning in January of 2024, I'll say that's when we really started to get the ball rolling here. And at that point in time, we were still looking at how do we do this in an equitable manner as we roll out our program with FHWA to where, asphalt, concrete, steel, and precast industries were all going to come on this journey together, with us. By January, in coordination with our governor's office and communication with those industries, we realized that the asphalt industry was the most mature, and it seemed as though that was originating from Napa and the Emerald Eco label, like Tom had mentioned. So at that point in time, we decided we were going to focus on asphalt only and figure out this new process of how we're going to develop these tools with asphalt, and then from those experiences, as the other industries become a little bit more mature, we will then take our experiences from asphalt and kind of duplicate those efforts with concrete as being our next industry that we'd like to pursue. So by April, we began participating in a Mid-Atlantic meetings to coordinate discussions with New Jersey, Maryland, Delaware, Virginia. I think at one point, Colorado was involved, and some other state DOTs. And the goal there predominantly or initially was that some of our suppliers in Pennsylvania also supply materials to Delaware, Maryland. And so we wanted to make sure that we were taking a similar approach and that our ask wasn't going to be vastly different from what they were being asked of in other states. By June, we had submitted notification to all of our producers in industry, actually requiring that EPDs were going to be required for submission in 2025 with all 2025 job mix formulas. So that was, up until that point, we were communicating, we were discussing, but we did not give them anything formal in writing stating that this indeed was our future. So by October of 24, we had partnered with the Pennsylvania Asphalt Association and FHWA, and we provided a webinar. And so we brought some suppliers in and we allowed our suppliers that had already started down this journey of developing EPDs to share that information with the suppliers that have not. And so at that point in time, that webinar allowed for a Q&A session and ultimately gave us a lot of really good questions that we needed to consider and have at that point. So that was very beneficial for the department so that we weren't making decisions that were going to adversely affect our business partners. In November of 24, we developed a standard special provision and a pay item that we were making an attempt to offset any cost to the asphalt producers. So this was rolled out in a very similar manner to what we've done with e-ticketing up until that point. And the goal was to try to offset that initial cost of them purchasing the software packages or the resources required for them to develop the EPDs for their individual plants. Our goal, and it seems like we're heading this direction with much success, is that pay item will not be included in our 2026 projects. And even now we're seeing the bid items, the prices are diminishing each letting just as a result of the initial upfront cost. But now that they have the tools in place, it does not seem like a very heavy lift for our suppliers to produce the EPDs. And the one thing that I want to note here that PennDOT decided to do differently than most other states that we were talking with, most states are collecting EPDs specifically on a project basis, where we decided that we wanted data on all JMFs. And so PennDOT had made a requirement, and we updated our Bulletin 27 requiring EPDs as part of the JMF submission. So we're collecting data on every JMF approved in the entire state instead of just on a project basis. And so we think that that'll help us to better establish our benchmarks as we move forward. So implementation. So like I mentioned, through that webinar in October, we were able to develop a frequently asked questions document. So we rolled that out in January of 2025. We've included the bid package, EPD special provision as well as the item. And then PennDOT developed an electronic construction materials management system that we use for all JMF submissions. And so we were very fortunate that with some minor modifications, we were able to add some fields for the contractors to provide us the A1, A2, A3 values that Tom had spoke of, as well as the total global warming potential for those A1 through A3 values. So in addition to the vendors providing us their job mix formulas for approval, we also get a PDF version of the EPD as well as those A1 through A3 values, so that we can eventually extract it into a spreadsheet and start working on our benchmarking efforts later on this year. And then, as well as in 2025, we have started our EPD collection. So the next slide I'm going to get into, we'll discuss where we are with our collection efforts at this point in Pennsylvania. So internal to our electronic construction materials management system, this data is updated April 14th. So we currently have approved 1,924 JMFs, and I guess let me back up. So we did have to establish some exemptions. Part of those exemptions came from the PCR itself, and then others were just how PennDOT does business in some of our rural areas. Not all of our producers supply materials to our construction projects. Some of them, it's small quantity batch plants that go directly to maintenance forces. So as such, we had no mechanism to help them to offset those costs. And we felt that it was such a small population that we were just going to allow those particular individuals for JMF supplied to maintenance projects only to have an exemption from the EPD requirement. And so as you can see here, we've had very few exemptions for the volume of EPDs that we've collected. We've had a couple that are missing data that we've had to go back and get corrected, or in some instances, they've provided us the metric ton instead of the short ton. And again, just part of our learning curve. And then we currently, as of the 14th, have 447 JMFs in our queue that have not been fully submitted yet. And so with regards to the exemptions, you can see here, 61 were due to new plants, 18 change of fuel sources, and 60 were for those maintenance projects that we had discussed. So where are we now? So going back to the data that Tom was speaking of with regards to Napa Emerald Eco Label, I wanted to see where did PennDOT stand in regards to everyone else. We knew that we were taking a different approach in our collection. Like I'd mentioned, it was by all JMFs instead of just on project basis. And so this was some interesting data that we were able to pull from Napa, looking at total number of organizations that have an EPD available. So PennDOT makes up 15% of that. Of the total available plants, PennDOT is 25% that have EPDs. So, that was interesting whenever we were looking at this, because I don't think PennDOT is typically considered a leader when it comes to EPDs or buy clean. We don't have any buy clean policies, and so we've often been told we'll talk to Colorado, talk to California, that they're leading the effort. But when it comes down to the actual data and the means of which we decided to collect it, we really find ourselves out ahead of the pack, and I'll show that on my next slide. So when it comes to actual published EPDs, Pennsylvania makes up 46% of all the EPDs in the eco label database. So we're pretty proud of that. It's something that we've shared with our producers and basically thank them for all of their efforts. And so with that being said, it's nice once we get into our benchmarking efforts that we have such a vast amount of data that we'll be able to see local to our region and to our state. So looking ahead into the future, we did have a couple areas where, like Tom had mentioned with the A3 categories, we had some concerns over the a low value with A3, and it just didn't seem right. And so we had reached out to NAPA to say, hey, is there any type of auditing process, or how should we handle this? We've spoke with the vendors, and their communication to us was they've input everything correctly, it was accurate, and they're that efficient. And so through that discussion with NAPA and discussing data integrity, we were asked to become one of 8 DOTs partnering with NAPA to consider a process to not only automate the EPD delivery, but also to help them to establish their quality control protocols, just to have accurate verification of foreground data, as well as any statistical triggers like what we encountered. So we're excited to use our 46% of our data to help NAPA and support them in their efforts. And again, just another great example of how we've been very fortunate on this journey to partner and collaborate with the asphalt industry itself. So one of the items that we're going to start to work on, and we have not yet, as we're collecting all of this data, is going to be our benchmarking, and so we're hopeful that NAPA will have a seat at that table with us and help us to establish those benchmarks so we're consistent with the industry, but also to help us to better understand how we need to look at all this data, because we're collecting so much of it. So as we start to look at benchmarks, whether it's by setting thresholds for gyrations, nominal aggregate size, performance grade binders, easels, but then also, do we need to take into consideration just the individual regions that we have? Some of our suppliers or producers have asphalt plants that are in quarries. Others are bringing their materials by water, some truck, but some train. So understanding that even though the A2 value is rather small compared to A1 and A3, it's still a factor. So we feel that we have enough data that we'll be able to make some educated decisions here and drive good business for both the department and our material producers. And then we want to continue to evaluate EPDs while also advancing the balanced mix design. And Tom did a great job explaining the benefits of that, because one of our concerns, like Tom had mentioned, we don't want to establish thresholds that favor underperforming materials. And, that's especially important to me, considering that my background is in maintenance. So how we see them being used in the future, we anticipate that EPDs will help us to establish good industry averages and benchmarks. We hope that they will help us to enhance efficiency in the industry, continue to use them as a tool to help monitor asphalt performance. Hopefully one day, be beneficial in modifying the mix designs and helping us through BMD to get a better performing material up front. And then ultimately, we're hopeful that will ensure an opportunity to reduce maintenance costs and resource consumption over time. So with regards to our EPD outreach or challenges, so sharing EPD collection and approval process across the 11 PennDOT engineering districts had its challenges. As we had shown before, we only had 14 EPDs, I think was the number on the slide, that were missing data. So there was a lot of people that we had to communicate with from the producer side, as well as internal and our materials engineers for the approval process. But all in all, it was challenging, but I feel that it went very well. when EPDs are submitted with values that seem to be out of line, that's one of the challenges that I don't think we've really overcome yet, and that's that ability to validate the data. So, that we're looking forward to that being something that'll come out of our cooperation and coordination with NAPA in the future. And then ultimately, our road ahead is still uncertain, and we believe that's a good thing. PennDOT's very fortunate that we, one, have so much EPD data that's being generated by our producers, but we also don't have any buy clean policies that are driving our end goal. So we feel that we're pretty blessed that by not having that policy dictating what we're doing, that we can work very closely with industry and making very good engineering decisions from an economical standpoint, trying to steal two of the three E's that Tom had discussed, but really just using the data that we're collecting to drive good business decisions instead of trying to make business decisions and enforcing the data into it. So we are very excited with that. And then we have established a resource account that we've encouraged our industry business partners to use as they have any questions, comments, concerns, and the same for all of you on this call today. If there's anything, any additional information you would like to, like us to share with you, or any questions you may have, there's a website that we do monitor, and it's specifically dedicated to EPDs. And so with that, I guess that concludes my presentation.
So I'm going to just wrap us up as we discuss kind of some recommendations based off of Tom and Dean's content that they shared with us. I like Tom's 3 E's. You hear people, profit, planet. You hear a couple different ways of summarizing sustainability. But Tom, I really liked that, and you really need all three. You need obviously engineering, economics, but and environment as well. Today we focus a lot on environment, but I think both of you even kind of made the point that EPDs are not the end all be all. I mean, ultimately, what we want is longer lasting payments. And I think all of us hope to see as EPDs continue, or even now that they have been paused in many places, but just the general idea of eco accounting, we really as an industry need to push to include the construction phase in the near future, and then ultimately the full life cycle as we move forward. I thought Tom's examples of traditional super pave mixed designs looking good early, but then ultimately not being as good whenever you included the full life cycle. I thought that was really helpful. And honestly, that's a story we've seen before, right? We saw that with the overutilization of RAS and shingles, kind of without thinking about what are we doing to our mixes. They looked great environmentally and they looked great economically, but I think we all learned some really hard lessons. And because of that, don't be surprised if BMD mixes have higher cradle to gate EPDs. That's not, we've got to make sure as an industry that we don't see that as a bad thing. Also, EPDs shouldn't really be compared across districts or state lines or really regions, just because of materials are different. And I thought Tom's example of aggregates in Florida was a good one. Florida doesn't have a lot of local aggregates available to them, and so they're hauling in quite a bit of material from elsewhere, and more so than most others. But if we keep performance and better performing, long-lasting asphalt pavements as the ultimate goal, and EPDs are just a way of achieving kind of an eco accounting. That's kind of the main purpose. They're not really intended to be a mixed design tool. And then I thought from Dean's work, Dean, that was a really helpful kind of summary of all that PennDOT has done. And kind of my main takeaways are collaboration and buy-in. They seem necessary. I mean, honestly, this is really simple, right? You can say that about most things, but as you started discussing kind of the buy-in from PAPA and the buy-in from industry, and then buy-in from NAPA, and then the different divisions inside the DOT, and then piecing all that together with a consultant. I think that's a great example of how to go about doing this. It's not going to build itself, and you don't want to build this in silos. So collaborating across those groups is really necessary. Both of you did a good job, I think, of highlighting the tools that NAPA makes available to their members. And I thought it was excellent, Dean, how you mentioned, from a DOT perspective, reaching out to NAPA for help. And then actually you guys have now, formed a pretty strong partnership, being one of the DOTs that's doing this. So well done to that. And for anybody else who's kind of considering this, or who may be in a state that is moving forward with EPDs, utilize NAPA's tools. They're great. And then finally, and kind of just to sum it all up, and Dean, you made the comments there at the end. Database decision making, that's the way to go. We ought not let don't let the tail wag the dog, so to speak. And honestly, as engineers, and many of us are decision makers based off of data. We don't need to have a conclusion in search of the data to support it. Let's go where the data takes us, and let's solve problems using that approach. So I want to thank both of you. That was really helpful. I thought it was really well done. Thank you so much to both of you. So just to kind of wrap us up, we do have time for questions and answers. And I see a handful of questions have been coming into the chat. So y'all keep getting questions in there. So Travis, I'm going to kick it to you.
Okay, that sounds good. That sounds good. Thanks, Nathan. Hey, Tom, one of the questions I had there, and we've talked some about making sure that we understand that those BMD EPDs may be higher. Do you have a concept of about what you're seeing on a percentage difference for that?
So for every 10th asphalt, you start seeing the EPD come up 3 to 4.
Okay.
Okay. And the example I just gave, the EPD was 6% more because it was 0.5% more asphalt.
Okay. Okay, great.
What about on the increasing wrap? If you go up 10% wrap, what do you see?
So you look at it straightly from binder replacement.
Mm.
So if you're reducing that by 10%, you're going to see your EPD start clocking down 3 to 4 or so. Okay.
And so do you get a credit from replacing virgin aggregate as well?
A little. It all depends on the A2 number, because you do have the process in getting the wrap there as well.
Gotcha.
Okay.
Yeah. But the big driver on the material side of the house is the virgin binder content.
The liquid. Okay.
Well, it's that way with costs, it's that way with performance, and now we hear it's that way with environmental stuff as well. Not surprising.
Shouldn't surprise.
Yeah.
Yep.
Yeah. Hey, Dean, one of the questions we got for you here is have you seen your producers make any sort of shifts or any changes based on their EPD numbers that they have seen? And if you have, what would those changes be?
So I can't speak to any exact changes yet, but I did have one producer share with me that, and I don't know how many plants exactly they have, but that they are estimating that they spent about $3.5 million on wet aggregate last year as a result of now this new way of just viewing their business. They're finding it as a tool to I guess that they'll ultimately use in the future to improve efficiencies. They knew they were spending the money. They knew that they were dealing with trying to burn off moisture from the aggregate, but I think the EPD allowed them to really quantify that, which I found to be very interesting in that regard. When we first started this journey, I viewed EPDs as environmental, and very quickly talking with our producers, there's very much an economical component, if not, the most important component of the EPD. It just gives you a different unit of measure other than dollars. And, I think that, like Tom had mentioned, when you look at it from the LCCA standpoint, there's really some value to show where spending the money up front and putting the better material down up front will give you the better product over the life of it. And I think that's where EPDs will help us to justify in a low bid environment the durability and longevity of BMD. One thing that I do want to comment just to everybody. So Pennsylvania does have a high wrap specification that allows up to 50% wrap for low volume roads. So that's something that, you know, we haven't really started digging into the EPD data yet, but I'm very curious to see, you know, going back to that question of how does wrap impact those EPDs. We know that we are going to have higher wrap asphalt mixtures, and we are going to have the EPDs from that. So, you know, I'm hopeful by this time next year we have a much better understanding on the various mix designs and, you know, how BMD can play a factor into this. But then also knowing that we do have suppliers that are really pushing the envelope on higher wrap mixtures. And I know myself personally in maintenance, we have some county maintenance organizations that for quite a few years now have been placing mixtures of 41, 42% wrap for 19 millimeter binders. And if I recall correctly, whenever that specification was developed, I think it was developed more of like an ID2 specification, which did increase the amount of liquid instead of counting on the benefits of the wrap. And so I think in turn, I discussed this with Tom previously, because of the higher wrap, we're getting a tighter mix because there's a little bit more fines in it. And so we're finding with our maintenance forces that the workability is there, you know, the compaction efforts are, I don't want to say simplified, but it's not a very difficult material to work with. And we're seeing to where it's weathering over a winter season for us. And we're using it as part of our preparation process in advance of our seal coat treatments the following year. So, you know, we're seeing some value with the higher wraps, and I'm curious to see what we gain from the EPD data that we're going to collect from that. So if anybody has any additional questions on these high wrap for low volume roads, we do have some specifications in Pennsylvania.
Well, and if anyone's interested, Dean's email is here on the screen. You can read him. You can reach him there. Dean, I will make just one brief comment. I am constantly amazed how many how many complex problems have a solution that is so simple. Something as simple as just quantifying how much water you're buying in the aggregate. I heard a contractor say they saved 30% in energy savings just by paying more attention to their hot oil system in their asphalt plant. I mean, some basic stuff that has such a tremendous impact, not just on an environment, not just on the economy, but all of it. I mean, even your example there of the dust coming from 50 or the fines coming from 50% wrap mix is actually creating a workability benefit. So I love I think holistic thinking about asphalt mixes is great. So thank you again. I thought this has been one of our better webinars. I really appreciate both of you, Tom and Dean. So I'm going to close this out. If you want more information, our website, we're at ncat.us. All of the reports that we've written, you can find here. These are kind of just the test track reports, but you can just go to our research, and we've got 30 years of test track and NCAT reports. So lots of good information there. Travis has a great training program, and his Training in Your Pocket content is constantly being updated. Really short, simple, nerdy, humorous videos just to explain the basics of some of this stuff. Again, because as John Wooden, UCLA basketball coach, said, champions are brilliant at the basics. And if we can understand the basics, we can solve some really complex problems. And Travis has a pretty funny and innovative way of tackling that in the Training in Your Pocket program. If you want more formal training, obviously, Travis runs a whole training program, and we would be happy to kind of answer your questions. So you can find that information on our website as well, both for agency folks and industry folks and people who kind of find themselves in between. So with that, I do want to introduce next month's topic. It'll be on the use of recycled plastics in asphalt pavement. This will be on May 16th. Note, this is on a Friday, not on a Thursday. The reason for that is in 1 month, we will be hosting the NCAT Minroad sponsor meeting. And I cannot give a tour of the test track while hosting a webinar at the same time. I'm still working on that technology, but we're not there yet. So our webinar will be on a Friday, actually for the next 2 months, one because of the sponsor meeting, and then in June because of the federal holiday for Juneteenth. So we will have a slight deviation from the schedule for the next 2 months, but we will continue. And so please join us May 16th. Again, that's a Friday, same time though, to discuss kind of the status of the use of recycled plastics in asphalt pavement. Thank you everybody for your attention and attending today. Yes, this presentation will be made available later online to Angus's question. So thank you again. And if anybody has further questions, you can shoot us an email. Thank you for attending, and we'll see you next month.